What's up, everybody? Let's go ahead and talk about the things coming your way this week. Um, as usual, recently, we're not going to have a formal Zoom meeting, but if you need me to have a Zoom meeting with you, please get in touch with me and we'll do one in the afternoon during office hour time. So, yeah, if you need me, please let me know and we'll do a Zoom. If you have any questions at any time, shoot me an email and I will get back to you as soon as possible. Um, but yeah, let's talk about this week. Monday, there's this assignment called Getting to Know the Elements. There's a periodic table that's covered in pictures, and you will use those pictures and the data on that table to help you answer the questions in your assignment. So you'll kind of need to have up that PDF of the periodic table with pictures, and then the Google Doc with the questions. You'll need to have both of those up at the same time so you can answer from the pictures in your questions. You're going to type in your answers, but you'll find them in those pictures. So you'll need that document to enter the things in your Google Doc. Do that the first couple days this week. Wednesday, there's an Edpuzzle video about balancing chemical equations, and the video is going to walk through what balancing equations looks like, which I'm going to walk through that with you in a minute. And I'm actually going to use a portion of that same video to help you know what to do when it comes to balancing equations. But yeah, Wednesday, do that Edpuzzle. And then the end of the week, Thursday, Friday, there's a simulation. You will go to the website that's linked and also open up the Google Doc. So on one side of the screen, you should have the simulation website pulled up. And yes, the website works. I've checked it. I've triple checked it. It works on Chromebooks. But pull that website up for the simulation, pull the Google Doc up, and the Google Doc will walk you through what exactly to do. And as you walk through the simulation, you'll put your data and your answers in the Google Doc and just do exactly what the Google Doc says. And at the very bottom of the Google Doc, you're going to practice answering how to balance a few equations, which today's lesson from me that I'm about to go through with you talks about how to balance equations. So here in a second, we're going to shift gears. And first, you're going to see a video of someone really breaking it down, and it's very colorful, and you can see how they used colors and dots to show you how to balance equations. The trick about balancing equations is you're going to be given two things on the left side of your reaction. I said two, it could be three, it could be four, it could be whatever. You're going to be given a few things on the left and a few things on the right. And your goal is to use a little bit of math to make sure you have the same amount of elements on the left as you do on the right. So if you wind up having 5 oxygens on the left, you got to have 5 oxygens on the right, or do a little math until they equal on both sides. The things on the left are called the reactants because they react together. And the things on the right of the equation are called the products because it's the products you get when those things react together. I'll play the video for you here in just 1 second to show you how to do that. And then I'm going to break down some examples for you as well. So here, let's take a second and look at this video that explains to you how to balance equations.
To be able to show what's happening in a chemical reaction, you need to understand chemical equations. One way to show a reaction is with a word equation. Imagine we're told that methane burns in oxygen, turning into carbon dioxide and water. On the left-hand side of our equation, we have the methane and oxygen that reacted together, and we call these the reactants. On the right, we have the molecules that are produced, so in this case carbon dioxide and water, which we call the products. And in the middle, we have a single arrow to show that the reactants react completely to form the products. More often though, instead of writing these word equations, we write symbol equations, using the chemical symbols of each molecule involved. So we would have CH4, which is methane, plus O2, going to form CO2 plus H2O. Notice that I've put O2 rather than O. That's because oxygen exists as a molecule made up of 2 atoms. So whenever you include oxygen in a reaction, you have to put O2. Just like for chlorine, you'd put Cl2, and for nitrogen, N2. Anyway, getting back to our equation. It's not quite right just yet, because we haven't balanced it. In order to be balanced, chemical equations need to have the same total number of each type of atom on either side of the arrow. In our example, we can see that on the left of the arrow, there's 1 carbon, 4 hydrogens, and 2 oxygens, whilst on the right, there's 1 carbon, 2 hydrogens, and 3 oxygens. So our equation isn't balanced. Somehow we need to increase the number of oxygens on the left-hand side and increase the number of hydrogens on the right. Now, it's absolutely fine if you can't work out how to balance it in one go. Often, balancing equations is a process of trial and error, where you keep on changing numbers until you get the answer. The first rule of balancing equations is that we can't change any of the little numbers. This is because doing so would mean that we were changing the actual type of chemicals in our equation. For example, we couldn't change our O2 to an O3, because O3 is an entirely different substance, which isn't oxygen. Instead, we have to rely on changing the big numbers in front of the different elements or compounds, as this number just represents how many of that substance there are. So to increase the number of oxygen atoms on the left, we'd have to put a 2 in front of the O2, meaning we now have 2 oxygen molecules, and therefore 4 oxygen atoms in total on the left-hand side. This might seem a bit weird, as we only need 3 oxygen atoms to match the right-hand side. So shouldn't we just make it 1.5 molecules of oxygen? Unfortunately, we can't. When balancing chemical equations, another rule is that we need to keep to whole numbers. And so we have to round up to 2 instead, and keep 4 oxygen atoms. This leaves us needing 2 more hydrogens and 1 more oxygen on the right, which we can get by increasing the number of water molecules from 1 to 2. So we now have the same number of each type of atom on both sides of the reaction, and so we're done. Let's quickly try one more example. Sulfuric acid plus sodium hydroxide goes to form sodium sulfate plus water. On the left, we have 3 hydrogens, 1 sulfur, 5 oxygens, and 1 sodium, while on the right, we have 2 hydrogens, 1 sulfur, 5 oxygens, and 2 sodiums. Although it's up to you, I recommend balancing the least common elements first, which in this case would be sulfur and sodium. As sulfur is already balanced, with 1 on either side, I'd look at sodium, where we can see that we need 1 more on the left. So to fix this, I'd put a 2 in front of the sodium hydroxide, giving us 2 sodiums. Then if we count all of our atoms again, we can see that we need 2 more hydrogens and 1 more oxygen on the right-hand side. This is a pretty common problem to have, and we can fix it by adding 1 more water molecule to the right. As always, when you think you're done, just double check to see if it's balanced. So we've got 4 hydrogens, 1 sulfur, 6 oxygens, and 2 sodium atoms on each side. So this is exactly balanced, and we're finished.
Okay, now that video does a really, really good job showing you how to break down what to do. So I'm going to go through some examples here and cough, cough, wink, wink, nudge, nudge. These examples might be familiar if you're working on the final assignment of the week. I'm just throwing that out there. Anyway, let's work through these examples together. Now, what you do is you take all the elements on both sides. Now, I like to write things out underneath because it helps me see what I'm working with. So I'm just going to write out, we have iron, we have oxygen, we have carbon. On this side of the arrow, we have iron, oxygen, and carbon. Now we start with, it looks like 2 irons here. How many oxygens? We have 1, 2, 3, 4, because we're looking at everything on the left of the arrow, so 4. And we have 1 carbon. On the right, we have 1 iron, we have 2 oxygens, and we have 1 carbon. Okay, so as we can see clearly, these are not balanced. There are different amounts on both sides. So I'm just going to pick one to begin with. We have 2 irons on the left and 1 on the right. So what we have to do is pick a number that we can multiply our elements by to make it have the same amount on both sides of the arrow. Now, as you can see, we have these little subscript numbers. Those numbers, you have to think of them as locked in place. They are permanent. You cannot change them. But what you can do is put a number in front of the element in these blanks that multiplies the whole element or compound by that many. So like this is just an example. If I were to put like a 3 here in front of this, that would be 2 times 3 to give me 6 irons and 3 times 3 to give me 9 oxygens. Now I'm not going to put a 3 there, but that's what that would do if I did put a 3 there. If I put a 2 in front of this iron over here, then suddenly it's multiplied by 2 and I have 2 irons. So what I'm going to do is look at my unequal elements, and I'm just going to start with iron. I have 2 on the left and I only have 1 on the right. So what I'm going to do is I'm going to multiply this by 2, and I'm going to cross this out because now I have 2 irons. So those are equal. That's great. As you can see over here, I have 4 oxygens because 1, 2, 3, 4. And on the right side of the arrow, I have only 2 oxygens, but I need 4. I can't make this one smaller. I have to make this one bigger. So 2 times 2 changes my oxygens to 4. But here's the thing. This also changes my carbons to, instead of 1, it's 2 times 1 for my carbons. Suddenly I now have 2 carbons, which means, oh no, I need to figure this out and go back over here and give myself 2 carbons. But we're going to run into something here. We're going to run into a problem, which that's okay. When we are balancing equations, you run into these problems. Balancing equations is just a lot of troubleshooting until you get it right. So if I have a 2 here, I have to have a 2 here. That changes my carbons into 2. It changes my oxygens into 1, 2, 3, 4, 5. Suddenly I have 5. So, oh no, this messes up things a little bit. What I'm going to do is I have to somehow make this a whole number. So the next number up is what I'm going to change this to. I know this is so weird. 3. Now I have over here 3 carbons. Over here, I have 3 plus 3 carbon, or excuse me, oxygens, which means now I have 6 oxygens, which means I've got to go back over here and have 3 and 6 oxygens. But if you look, I'm going to put a 3 here. 3 times my 1 carbon, suddenly I now have 3. 3 times my 2 oxygens, suddenly I now have 6. And see how that process of troubleshooting, just until everything is the same, we are good to go. So 2 irons on the left, 2 irons on the right, 6 oxygens on the left, 6 oxygens on the right, 3 carbons on the left, 3 carbons on the right. Those things are equal now, so we can be done. Now, whenever you have a blank, these are equal, so we know we don't have to add something there. You have 2 options. You can either just leave it blank or put a 1 that tells me you thought about it and you knew that nothing goes there, because 1 times this means it stays the same, because 1 times something is that something, it stays the same. So that was a bit of a process, but that's how balancing works. They seem tough, but they're really not. You're just troubleshooting until you get it right. If we look at the next one here, on the left, we have nitrogens, hydrogens, oxygens. On the right, we have nitrogens, hydrogens, and oxygens. We have 1 nitrogen, we have 3 hydrogens, we have 2 oxygens, and on the right, we have 1 nitrogen, 1, 2, 3 oxygens, and 2 hydrogens. Okay, this one is going to be quite a bit of back and forth until we get it right. So we just kind of need to pick a spot to start working with. Let's work with our ends. Let's see. Well, the ends are equal. Let's not work with the ends. Let's work with the H's. 3 and 2. So we know that the number that they're going to go into is some kind of a variable where 3 and 2 both can go into it. So it might be 6, it might be 12. It's going to be one of those numbers. So let's start with that. 3 here, 2 here. 6 is the first one they can go into. So let's just multiply each of those by each other till we get 6. H2. So we're going to multiply by 3, which changes my H is over here into 6. It changes my oxygens as well into 1, 2, 3, 4, 5. On the left, if I multiply this by 3, I should multiply this one by 2. Well, that changes a whole bunch of stuff. That gives me 2 nitrogens. That gives me 6 hydrogens. And that gives me, well, my O's actually stay the same. We can see already that doesn't work. Okay, well, what's the next thing that 2 and 3 can both go into? Well, we already tried 6. They can't go into 7 or 8 or 9 or 10 or 11, but they can both go into 12. So let's back off here and multiply by something that makes it 12. 3 times 4 gives me 12 hydrogens. So I now have 12 hydrogens. That also affects my nitrogens. I have 4 of those now. Okay. Over here, I got to do the same thing. 2 times what gives me 12? Well, in this case, I'm going to put a 6. So 2 times 6 gives me 12 hydrogens. That changes my O's. So right now I have 6, 7, 8 O's. Okay. We can see we're on the right track though, because our hydrogens are equal. So we're on the right track. The next thing we need to do is figure out a way to make our N's equal. Well, over here we have 4. So this times what is going to give me 4? 1 times 4 gives me 4. So I'm going to put a 4 here. So now I have 4 nitrogens. Now this does affect my O's once again. 4 times 2 is 8 plus those 6 more. So 8 plus 6 is 14. Okay, I have 14 O's. All that's left is this blank right here. 2 times what's going to give me 14? Well, 2 times 7 is going to give me 14. So I now have 14 O's on this bad boy, meaning if we check up everything we just did, 4 nitrogens, 4 nitrogens, 12 hydrogens, 12 hydrogens, 14 oxygens, 14 oxygens. So those numbers are what makes our equation balanced. I know this is crazy. This is kind of tough. But once you start doing that back and forth troubleshooting, you're gonna eventually get it. I promise it'll click. Let's do one more example together. And then you guys can work on the ones in your final assignment this week. Cough, cough, wink, wink, nudge, nudge. Make sure you look at these examples. But let's start. We have iron, we have sulfur, we have oxygen. On the right side of the arrow, we have iron, sulfur, oxygen. We have 1 iron, we have 1 sulfur, we have 2 oxygens. We have 2 irons, we have 1 sulfur, and we have 1, 2, 3, 4, 5 oxygens. So those are clearly out of whack. Those are not equal. Let's see what we can do to start making things equal. Over here, I have 2 irons. So you would think, let's start over here. Let's put 2 irons, 2. So that changes my irons to 2, my sulfurs to 2. Well, if that does that, I have 2 sulfurs. Well, I need to go back over here and get 2 sulfurs. So I'm going to do this, multiply by 2. Now I have 2 sulfurs, but that messes with my oxygens. 2 times 2 is 4, plus these 3 is 7. Well, now I have 7 Okay, 2, 2, 2, 2, 2, 7. We are still not equal. That means somewhere in this mix, we've got to figure out a solution of what we can change to make things right. One of the quickest ways to do it, and this only works in situations where you have an odd number and an even number, is to take one of the ones you already have and just double it. So using that trick, I'm going to erase this one and just double it. So 4, I'm going to put a 4 there. That changes my irons to 4. That changes my sulfurs to 4, which means I need to go back over here and make my irons and my sulfurs be 4. So I need to multiply this one by 4 to get 4 sulfurs. So my sulfurs are now 4. That messes with my oxygens. Now it's 8, 9, 10, 11. I also need 4 oxygens. So I'm going to multiply this one by 2 because I already have 2. So 2 times 2 gives me 4 irons. And it changes my oxygens. 2 times 3 is 6. And 4 times 2 is 8. So 6 plus 8 is 14. So now I have 14 oxygens. I also need 14 oxygens over here. 2 times what is going to give me 14? It's going to be 7. So when I mark this off, 2 times 7 is 14. Now I should be able to count all this out and everything equals 4, 4, 14, 4, 4, 14. So 4 irons, 4 irons, 4 sulfurs, 4 sulfurs, and 3 times 2 is 6, and 2 times 4 is 8. 6 plus 8 is 14. 7 times 2 is 14. So that one is worked out now as well. You'll notice there's one additional on your assignment than these examples, and I would like you to take a stab at that one on your own. Okay, I know balancing equations. It's new, it's strange. It can definitely be a little tough the first time you're ever doing it. So as you are working through these, please ask me for help if you need it. Email me questions, refer to this video, because again, cough, cough, nudge, nudge, wink, wink. These examples may or may not be on your assignment. Check them out. But what I want you to do is practice them and ask me for help if you need it. Please reach out. If you see me in person, definitely ask me while you're sitting in person for some help if you need it. I will gladly walk you through them again. If you have any questions, as always, send me an email and I will absolutely help you as soon as I can and as best as I can.